The model did not fail because it forgot how files work. It failed because a tool handed it exactly one page and the harness did not make page 2 obvious. This is fluid coding in AI. Today we are looking at Nemotron 3 Ultra to NemoClaw as a harness engineering story, not a model victory lap. The previous Nemotron 3 Ultra baseline was mostly about the model and endpoint. NVIDIA published it as a 550 billion parameter model with 55 billion active parameters, up to 1 million tokens of context, reasoning budget controls, and big first-party coding and agent benchmark numbers. That matters, but none of that by itself proves a reliable coding agent. The old baseline had a clear gap: no local benchmark run, no Deep Agents profile applied, no NemoClaw sandbox path, and no trace, cost, or failure artifact for this inspection. So this episode cannot claim local reproduction. It can do something more useful: inspect the published path and ask what actually changed around the same model. The NemoClaw story adds 3 layers. First, the open model layer, Nemotron 3 Ultra. Second, the tuned harness layer, LangChain Deep Agents code with a Nemotron-specific profile. Third, the governed runtime layer, NVIDIA OpenShell and NemoClaw, where sandbox policy, inference routing, credentials, networking, and audit evidence become part of the system. The cleanest example is almost funny in the way only agent bugs are funny. In NVIDIA's write-up, the baseline passed 20 file operation tests and failed one. The task needed a value later in a big file. The agent read the first page, treated that page as the whole file, and answered the wrong value. Congratulations, we reinvented pagination. The fix was not model retraining. It was a better contract. The profile changed the read file instructions so an exact line limit means there may be another page. It also added middleware that notices this case and tells the agent to continue with the next offset. After that fix, NVIDIA reports the file operation suite moving to 21 passed and 0 failed. Here is where my expectation changed. The launch story has strong benchmark language, but NemoClaw's own audit matrix says the Deep Agents and Nemotron rows are still not yet run until committed evidence or stable CI links are attached. That is the whole episode in one contradiction. The harness path looks real, but the managed runtime proof is not the same thing as the launch claim. The prompt changes are not decorative. The profile tells the agent to plan briefly, parallelize independent reads and lookups, verify state with tools, mutate before claiming a requested change is done, avoid retrying the same failing call unchanged, and prefer domain tools for domain questions. That is practical agent control policy written into the harness. Then the profile adds a lot of middleware. There are progress budgets, policy nudges, file system tool call shims, read file continuation notices, tool retries, rate limit retries, chat NVIDIA compatibility handling, reasoning tag cleanup, text to tool call parsing, follow-up discipline, entity resolution guards, and final answer guards. At that point, the agent score is not just model intelligence, it is model plus repair system. The profile is also careful about where it activates. It registers specific Nemotron 3 Ultra model IDs across providers like NVIDIA, Basseton, Fireworks, OpenRouter, Nebius, and Together. It does not just blanket an entire provider. That is good engineering because a provider-wide patch could silently change unrelated models. It also creates a simple failure mode. The wrong model ID can mean the profile never turns on. Now move from Deep Agents into NemoClaw. OpenShell puts the agent in a sandbox using controls like landlock, secomp, and network namespace isolation. NemoClaw's managed Deep Agents path uses controlled launchers, managed state, routed inference, and a read-only managed Python environment. That makes the runtime safer, but it also means the benchmark environment changed. Approval gates matter too. NemoClaw says interactive thread auto-approval is disabled by default. Enabling it requires an explicit rebuild with thread opt-in, and even then it does not bypass network policy, credential isolation, managed inference routing, MCP validation, or the other runtime controls. So when someone says an agent was auto-approved, the useful follow-up is, auto-approved for what, for how long, and behind which remaining gates. Networking is another quiet source of benchmark drift. NemoClaw's baseline policy allows local inference, while external providers route through the OpenShell gateway. Unknown endpoints are blocked, logged, and shown for approval. Web search through Tavily is not magically available inside Deep Agents code either. It needs explicit egress policy and credential registration. A sandbox without network access is a different agent than a sandbox with package installs, search, GitHub, and telemetry. For harness tuning, traces are gold. You want tool calls, tool results, file mutations, final answers, token usage, cost, and enough trajectory detail to replay failures. LangChain's evals describe that kind of end-to-end behavioral testing. NemoClaw's managed launchers, though, disable native Langsmith tracing and ambient open telemetry exporter configuration by default, then emphasize sandbox logs, session state, trajectory files, token usage, and cost metadata. That is not worse. It is a different evidence pipe. The cost number is the flashiest part. LangChain says Nemotron 3 Ultra with the tuned Deep Agents harness scored 0.86 at $4.48 in its agent-eval suite, while the next closest model costs $43.48. That is a strong claim, but it is first-party benchmark-specific and not recomputable from the public page alone. Still, if that cost shape holds for your workload, it changes the engineering loop. Cheaper inference means more eval variants, more regression runs, more harness experiments, and less fear of trying one extra recovery policy. But total cost still includes retries, context size, provider pricing, blocked network attempts, approval delays, and failed runs that burn time without producing useful work. Cheap tokens do not make messy automation free. I have checked, painfully. So is tune the harness, not the model. Reproducible engineering? Yes, when the failure is explicit, the patch is inspectable, the validation run is visible, regressions are checked, traces and costs are preserved, and held-out tasks still improve. But if the public artifact is only a score, a large model-specific profile, and a missing audit row, then the honest label is promising scaffolding, not settled reproduction. That is the practical takeaway. For coding agents, the harness is not plumbing. It is part of the product, part of the benchmark, and part of the security story. If this helped you separate model claims from agent system evidence, like the video and subscribe to Fluid Coding and AI.